A methanol-powered dragster travels a quarter mile from a standstill. The final speed of the best dragster will reach 300 miles per hour. A. Convert all the units to standard SI units. Normally, I wouldn't ask that in a question. You could use Google to convert them. So if you were to use Google, you literally type convert 0.25 mile to meters, and it would do it. You would write convert 300 miles per hour, 300 mph to ms, and it'll do it, or take you to a page that will do it. Or you could do it with dimensional analysis. It's fine, but we'll just go with the values that we have. So the final velocity is 134.112 meters per second. That's equal to 300. And the distance of a quarter mile is 402.336 meters. So we'll use those values. In fact, why don't I just go ahead and make those corrections here, or those additions here. Quarter mile is 402.336 meters. And that's my conversion from Google. 300 miles per hour is 134.112 meters per second. All right, so let's go on to B. Assume the dragster's acceleration to be constant. What will it be? All right, so let's take a look at what we have here. Start with a picture. Let's do my dragster. So I'll make this my dragster. Ooh, fancy. And then over here is the dragster. Got shorter. So at the beginning, it starts from a standstill. So it's basically going to start from rest. So now the initial velocity is going to be 0. It's going to travel this huge distance here, this quarter mile, 402 meters with all the decimals. And it's going to reach a top speed at the end of 134 meters per second. Now, of course, I've got more decimals than this on my numbers. And I want to find the acceleration to begin with. So part A. Okay, I'm going to find acceleration. And let's look at my givens here. So it's going to start from rest. Final speed is 134 meters per second. And my distance, oh, let's back up a second here. Let's get this with all the decimals. 134.112 meters per second. And my distance, x naught, 0, that's where I'm going to start. And x is going to be equal to 402.336 meters. And I'm looking for the acceleration. All right, I got v naught xxa. I don't have t, so that kind of gives me a hint. I'm going to use the equation without that. So that's going to be v final squared is equal to v naught squared plus 2ax. And I'm looking for a, so I got to isolate my variable. So 2ax is equal to v squared minus v naught squared. And ax is equal to v squared minus v naught squared over 2. So a is equal to v squared minus v naught squared over 2 divided both sides by x. So that's going to be the final velocity, 134.112 meters per second squared, minus starts at rest, so that's 0, divided by 2 times x, 2 times 402.336 meters. And when I do that, it's going to give me an acceleration. So I'll write it over here. An acceleration equal to 22.4 meters per second squared. All right. Let's go on to part B. So I'm going to go ahead and erase a bunch of this in order to find part B. So let's see what I can do here. It's not letting me erase. So let's just do this. Okay, part B. Assuming the dragster's acceleration to be constant, what will it be? I just found that. Let's do part C, sorry. Part C, how much time will the dragster take to finish the quarter mile? Alright, so part C, I'm looking for the time to finish. Time to finish. Alright, so in part C, I'm looking for T. And I have all these variables, V, V naught, X, and I'm looking for T. So I'm going to use something about the average velocity to solve this. I know the average velocity is V plus V naught over 2. The average velocity is also the displacement divided by the time, and I'm looking for the time. So what I'm going to do is I'll cross multiply, so that T is equal to V plus, or T times the quantity V plus V naught is equal to 2x. So T is equal to 2x divided by, in parentheses, or it doesn't have to be, I guess, V plus V naught. So T is equal to 2 times X. That's 402.332 or 336 meters divided by final velocity 134.112 meters per second plus 0. And then when I do all that, I get my time to be 6 seconds. 6 seconds. Its system